Good morning, Reyes. Which Reyes? Oh, this side is for today. Hold on, another side. Earlier. Thank you. All right. So everyone has the title Properties of Equality. We've been dealing with equations for the past week, and you probably heard prior to maybe taking my math class that an equation is kind of like a balance. Balance beam, a balance scale. Whatever you do to one side, you have to do to the other in order to maintain equality. Right? So, if I have, let's say, 2x equals 10, okay, that's an equation. I can do whatever I want to this equation, no matter what it is, so long as I do it to both sides. It doesn't matter what it is, as long as I do it to both sides, the equation will still maintain equality. So right now, don't even write this down. Just right now, just have the title, Properties of Equality. I want to demonstrate something. Mr. Adena, what's your favorite number? Look at what I'm going to do. I'm going to multiply by 6 on both sides. See what happens. What's 6 times 2x? 12x equals 60. Look at it. Notice how the equation is still an equation and it's still true. 12x equals 60. I can still solve for x. I didn't solve for x. All I did is multiply both sides by Ms. Herrera's favorite number. Ms. Rodriguez, what's your favorite number? 11. So let me write the original right here. That's 2x equals 10. So look what I'm going to do. I'm going to add both sides by Ms. Rodriguez's favorite number. But it's a balance, so whatever I do to one side, I got to do the other. So I'm going to add by 11 here. I'm going to add by 11 here. Look what ends up happening. Right here on the left side. On the left side.
11 plus 4.
Nice. I like how you said that. These are not like terms, so look what I got to write. I got to write 12x plus 11 equals 71. Still got an equation. This equation is still the same equation as 2x equals 10. It's still balanced because everything I did, first is Herrera's favorite number, then Rodriguez's favorite number, it's still an equation still in balance, and I still can solve it. Right. You see that? All I did is I have a balance. Whatever I do to both sides, it's still an equation. I want you to see something logically. Ms. Mendez, what's your favorite number? 13. Look what I'm going to do now. I'm going to subtract both sides by 13. Ms. Mendez's favorite number. Back to this Java crap. Get out of here. Watch. So let's see what ends up being here. Still a balance. I have 12x plus negative 2. Right? 11 minus 13 is negative 2 equals 71 minus 13. Whatever that is. That's 58. Still have an equation that's balanced. I haven't solved for x, mind you. That's obvious. I haven't solved for x. But what I have done is I multiplied by Herrera's favorite number on both sides. Then I added by Ms. Rodriguez's favorite number on both sides. Then I subtracted by Ms. Mendez's favorite number on both sides. I still have the same equation, though, that I started off with up here, 2x equals 10. I'm trying to bring out a feature of the equation that you guys are not aware of, but it's just pure logic. It's nothing mathematical, it's just logical. If you have two things that are equal, no matter what you do to the equation, as long as you do to both sides, the equation still maintains equality. Let's see, I multiplied, I added, I subtracted, now divide. I'm going to divide both sides by 2. I'm going to divide by 2 on this side and on this side. Let's see what I get. So 12x divided by 2 is going to become 6x plus negative 2 divided by positive 2 is negative 1. And then 58 divided by 2. What is that? 20. Help. 20 help.
20 help.
58 divided by 2. What does that count? How much? 29 help, that's right. Okay, there it is. So this bottom equation is still going to have the same solution as this top equation, which, and then I said x is going to equal to 5, because they can just divide by 2 and most likely you get x equals 5. I'll still get x equals 5 here, watch. I'll prove it. All right, let's see. Exactly, so let's get x by itself. Look at, I'll add 1 to both sides. So I have 6x equals 30. Divide both sides by 6. X is 5. Because I did every single step, I did something to both sides. Okay? Cool. Here we go. Now, what I just brought up to your mind was what we call a feature of equality or a characteristic of equality or a property of equality. Characteristics about you are maybe you like sports. What's a characteristic about you that's unique, Ms. Gilman? You're kind and friendly and amiable, and you have a beautiful smile. And then a characteristic about that, he loves music, and I like some of the music he likes, actually. He has some excellent bands that he wears. So those are properties or characteristics. Characteristics about me. Be nice.
Be nice.
I guess so. Yeah. So characteristics and properties mean the same thing. So the title of your notes, check this out, are properties of equality. Okay? Properties of equality, which I mean characteristics of equality. Now, on your notes, go to write example 1. Example 1. Right here. Example 1. Solve for x, provide an argument. Provide an argument. Now, when I say provide an argument, I mean justify every step that you make in solving for x in this equation. When I say provide an argument for your position on abortion, that means you're going to provide a reason for your position. Provide an argument for your position about who you're going to vote for, Donald Trump or Hillary Clinton. That means you're going to, so even if none, you'll give me a reason, a valid reason that substantiates and supports your position. So when I say provide an argument for solving for x, every step of the way we're going to provide a valid reason for why x is equal to something. Here's what I'm talking about. Ready? Now on your properties of equality sheet that you should have, there's 4 properties of equality, right? You guys can see that? Statement I'm justifying. A valid reason. So the first statement given, that's my justification. Second statement, that's my justification. Rodriguez, you said something right now? Like terms of x minus 3x is going to be a negative 2x plus 9 equals negative 5. Now, did I do anything to both sides of the equation there to get from here to here? I did not do anything to both sides. All I did is I simplified. The x minus 3x, I simplified the expression, so I'm just going to write simplified. See, I'm providing an argument. Right now is not the time, Doctor. Stay with me, come on. All right. Who got it there? What should I do now to both sides to solve for x? All right. Ms. Gonzalez, what do you think? What should I do to both sides to solve for x? Subtract 9. So now I'm going to subtract 9 from both sides, but I'm going to write the right. Oh, shoot. All right. What I'm going to do is the statement that results from subtracting 9 to both sides. What is the statement that results from subtracting 9 to both sides? It's going to be this statement. Watch. It's going to be negative 2x equals negative 14. This is a statement that I justify. After I subtract 9 to both sides, what's the result? Well, what gives me the right to say this? You have to imagine sort of like a lawyer or a judge in some mathematical court of law that asks you, what gives you the right to say this? Well, Your Honor, this gives me the right. The subtraction property of equality. I'm going to abbreviate subtraction property of equality. You're kind of imagining you're in the courtroom, and every statement that you write or say or propose has to be justified by a valid reason. That's called argumentation. Subtraction property of equality. I'm abbreviating here. That's right here on the handout, Patrick. Let's do this. By the way, if you're wearing your red ribbon, I'm going to give you some magic money right now. Sure. Tell him, Rodriguez, tell him. Right. Gotcha. All right, here we go. So now, let's divide by negative 2. Watch what happens. I'm going to write the result of dividing by negative 2. What's the result of it? Well, it's going to be x equals positive 7. What gives me the right to say x equals negative or positive 7? Well, the division property of equality. The division property of equality. There's an argument. Guys, look at it. Hit it.
You want us to like wear the ribbon anywhere on our shirt?
Let's take with this one time. Red ribbon. Give me a second. Okay. Let's go over one more example and tackle red ribbon later. Let's do one more example. Yes, Mr. President. Hold on. There you go. Last example for now. Example 2. Here we go. Example 2 will be Here we are.
He really went in the woods.
Okay. Oh, that's a good one. All right, so solve for x. Justify each step. Justify each step. Right. When I say justify each step, that just means the exact same thing as provide an argument. That's all it means. Okay, you'll see it in both types of directions on maybe math exams and benchmark exams. Justify each step means provide the appropriate argument. Here we go. 7x plus 19 equals negative 2x plus 55. All right, let's do this. What gives me the right to say that equation? What's given. Always start off with what's given. All right. What shall we do now? We have variables on both sides. That's problematic. We have to get the variable on one side. I can add 2x to both sides, or I can subtract 7x to both sides in order to get the x on one side. So either way is fine. This is where that video that's on Google Classroom and that we watched 2 days ago, he said you have 4 different paths to go. The path I'm going to go down is what Ms. Ardetta just mentioned. I'm going to add 2x to both sides, here and here. Now I'm not going to justify this step. I'm going to justify the step that results from it. Watch. I have 9x plus 19 on the left, and I have 55 on the right. What gives me the right to say this? Well, what do I do to both sides? Addition, property of equality. Addition, what I'm going to do is I'm just going to put POE, property of equality. Just put POE, abbreviate. Right. Addition, property of equality. All right. Now we're going to subtract 19, obviously, to both sides. Now that we have x on the left side, we have it on one side. Now we can start proceeding to get by itself. So, what's the result of subtracting the same amount from both sides? Well, the result is this. 55 minus 19 is, I have no clue, 36 actually. So what gives me the right to say 9x equals 36? Well, this gives me the right. Subtraction, property of equality. Right? Notice how I'm justifying the statement that results from adding or subtracting or multiplying or dividing. I'm not justifying the actual doing of it. When I added 2x, I didn't justify that. I justified what resulted from adding 2x. Now let's divide by 9. Again, I'm not justifying this part. I'm justifying what results. What results from dividing by 9? Well, x equals 4 results from dividing by 9. So this is division, property of equality. Division, property of equality.